So what is the length of this? Let it be L. Next again, I will take another wire, which is a semicircle. What is the effective length of this? Will be again equal to L according to the diagram, and again the same current I flows. Again B bar is present. Look at the arbitrary shape conductor here. So there's a 2, 3, and 4. In all the cases, let I be the current. Then B bar is what about the force exerted by the field on this current carrying wire? In all the cases, it is same. In all the cases, it is going to be the same. In all the cases, I'm just write F1 equal to F2 equal to F3 equal to F4 equal to how much BIL. In short, let me write here. So what about the direction? Sir, in all the cases, yes, the direction also will be horizontal. F1, F2. So what we have to do, we have to just search for the effective length. Some correction is there. It just depends only on that effective length. Because L bar is there. No, what do you mean by L bar? L bar is effective length. Not able to understand. We'll do one thing. Let me take a semicircle here. That L bar meaning is what I'm trying to explain. So first, I'll take the effective length. So can I write down the L bar of this element? So shall I call L1 bar? Then I'll add up next effective length of this L2 bar. Then L1 bar plus L2 bar. The effective length of that. Call L3 bar. This I'll add up with this. Arrow I'll put it. Next again. L4 bar. So L3 bar plus L4 bar. Shall I go for 1? The effective length. This is one way of writing that, because L bar is what effective length of the conductor should be substituted in the formula, not the length of the conductor. So what is L bar indicates effective length of the conductor. So from where to where? From where the current entering to the where the current is leaving. So calculate the effective length. So nothing but you can, in terms of kinematics, displacement vector, similar to that. So effective length of the rod. So L in the formula indicates effective length, not length of the conductor. Is that clear? No? So what is the meaning of this L? This is or. So what is this current? The current is flowing like this, no? Actually, the current is flowing like this. So you can also take help of the displacement vector, because how you define current? How we define current? I is equal to eta q vd, and this diff velocity. So when the charge particle moves from here to here, what is the net displacement it has undergone? I think we are able to calculate the net displacement. So substitute that in terms of the diff velocity also you can analyze. So when it moves from one end to another end, what is the net displacement? The net displacement is what? Equal to this L bar only. Or when it moves from here to here. Anyway, I think I'll change the direction of current. Okay, no. So when the charge particle moves from this end to this end, How do it move? It will move in a curved path. But what is the effective length traversed by it is L bar. Or what is the displacement of charge particle will be L bar. Because how you define diff velocity? Displacement by time taken. Average displacement by time taken. So in terms of either charge you analyze or in terms of the vector notation, what you know, with that you can analyze here. Means no, if I current carrying loop, if I keep in a magnetic field, I'll keep in a magnetic field. So let the B bar into the plane. Now, what is the force acting on this one? What about the net force acting on this element or on this ring? So there's a ring of radius A, let me take here. So there's a iron ring. This is the external current. So how do this current will flow? Some external source. Let's not bother about all those things now. Let A be the radius of the ring. So what about the situation here? What is L bar for this? Will be zero, no? So the net force will be zero. Or in terms of mathematics, you can analyze it. You take a small element, this one, like this, you take small element. So what is the force acting on this? B bar current, B bar. Okay, I'll change the direction of current. Current, let me put here in this way. Now apply this one. B bar. So what is the force acting on this small element on the ring? I took it like this. So like this, you assume several elements. So if I take one more element here, how the force acting on all these elements will be? Radially outward. So what will happen to the net force on the ring? In fact, it's zero, no? The net force acting on the ring, in fact, it will be zero. That. Or in terms of mathematics, if you want to show that in terms of mathematics, you can take, I'll assume a length dl. Let the current I will be flowing. So then the force acting on this small element, let it be df. So then what we write, df, integral of df equal to I dl bar cross p bar. What is the integration in closed path? Not integral of only dl in closed path will become 2 pi a. But here I am writing the vector, no, integration in closed path dl bar. If I write only this, how much value of this will be? If I write like this, 2 pi r. I think I'll interpret this, it will be like this. But if you write integration dl bar in closed path will be zero, no? This quantity will be zero. Okay, fine. So just take help of the small basic mathematics. So therefore we'll get this much here. So what is the total force? No, F should be equal to 0. The overall force F must be 0. So therefore if a current carrying ring, it's kept in a uniform magnetic field, what should be the force on it? Will be 0 is what we can say. Will there be any tension set up in it? As we can take help of some small mathematics already you have come across at many places, no? This is theta, this is theta. Then how the tension will act? Tension will act radially or tangential to this. Then this will be theta. So then who will balance that deforming force? The deforming force is balanced by dF is equal to 2t sin theta. What is df? bi dl 2 theta. So what is dl? r 2 theta. So what is t equal to? bir. This is the tension in the ring. There's a new force you have come across called as Ampere's force. And so finally, what is our goal in physics? This force we will introduce in mechanics and we'll work out different numericals. That'll be our problem solving method. First, what happened? We'll check what is the Ampere force, how it has came. Then finally, what happened? What is our like a goal is in different situations, how that force will be acting. That one means you have to treat this is just like any other, like a weight, a spring. It's a conservative force, so you'll get SHM. It will mix it with surface tension. It will be mixed with friction, all the rolling motion, everything. That one. It's just current carrying wire will experience a force. Finish all. The rest all application problems you have to enter. You have to see that is a closed path all conditions, and effective length is what matters when you're calculating that force. Effective length is what you take it. I'm saying what is the net force on the ring? Zero, in fact. What is the net force acting on the ring? Is zero. If a current carrying loop kept in a uniform magnetic field will be zero. If a current carrying ring kept in a non-uniform magnetic field, current carrying loop, shall I say, ring or loop, either way same. Current carrying loop kept in a uniform magnetic field, net force will be zero. Current carrying loop kept in a non-uniform magnetic field, definitely be non-zero, because if the field on one off, here field is more than this one. So definitely net force will be upward. Able to make it out? This one? So this is about the basic introduction, this one. So we'll go for further. And now let me take two